When dealing with engine problems, an engine can pass a compression or leak down test and still suffer from an internal engine problem. Regardless of the troubleshooting result, technicians need to identify the exact fault in order to repair the problem. This module shows several inspection methods technicians can use that check the engine prior to removal. These checks may allow the technician to repair the problem without engine teardown or removal. Certain injector mechanical failures can cause a rich or lean code. When this occurs, a visual inspection of the intake may quickly identify the problem. Defects causing DTCs allowing excessive fuel flow, or bad injector seals, which allow fuel to flow with the injector turned off. For engines consuming too much oil, a cylinder wall inspection can identify scoring, while a piston top check may find a clean spot indicating oil washing past the rings. A foreign object sucked into the engine can cause internal damage. When this occurs, piston movement crushes the part against the cylinder head. The damage appears as marks on the piston top and combustion chamber. In addition to marring the combustion chamber, foreign objects may also damage the valve face or seat, increasing cylinder leakage and reducing the compression reading. Liquids such as rainwater, fuel from leaking injectors, or coolant from leaking gaskets can also damage the engine. When the liquid volume exceeds the combustion chamber volume, the piston stops prior to top dead center, creating a hydrolock. Because liquid presses evenly on all parts of the cylinder, the piston top and combustion chamber does not show any marks or nicks. Instead, the connecting rod bends to make room for the liquid. Once bent, the rod becomes shorter than the other connecting rods. This places the piston lower in the cylinder relative to the other cylinders. The lower piston height reduces the compression ratio in the affected cylinder and may cause a balance or misfire problem. But in many cases, these symptoms don't occur. Instead, the bend creates weak spots in the rod that fail over time. Finally, as engines age, internal components wear and fail. Most wear occurs at friction or contact points such as the valve face and cylinder walls. Poor fuel mixture and infrequent oil servicing can increase friction and create internal engine problems. The tip of the spark plug is part of the combustion chamber. It offers an easy window into engine performance. When removing the plugs, lay each plug on the workbench in the correct order. If one plug shows a significant difference in wear, color, or deposits, you've found the problem cylinder. Once you've removed the plugs, check each one for excessive wear, carbon fouling, and unusual discoloration. The electrodes of each spark plug should have sharp edges rather than rounded corners, indicating excessive wear. The ceramic insulator should be a smooth light gray or brown, without any uneven patches. Also inspect the mechanical condition of the plug tip. Check for a crushed electrode or cracked ceramic insulator, indicating mechanical damage. Finally, check for black deposits on the spark plug tip. Dry, flaky black deposits indicate a rich mixture, while oily deposits indicate excessive oil consumption. Few additional external checks can identify engine problems. First, you can use an infrared thermometer to measure exhaust port temperatures. If this test indicates a significant temperature difference between cylinders, focus your troubleshooting on the cooler cylinder. If you suspect an exhaust restriction, removing the air-fuel ratio sensor provides an alternative path for the exhaust gases. If all the exhaust gases come out the sensor port, check the exhaust system for a blockage. Earlier, if the connecting rod is bent, the piston sits lower in the cylinder at top dead center. To find this fault, use a long shank screwdriver to compare piston height at each cylinder. During the check, Remove all the spark plugs and place the screwdriver in a cylinder. Rotate the engine by hand until the piston arrives at top dead center. At TDC, note where the screwdriver meets the top of the plug hole. Using this mark, check all the cylinders to make sure the mark matches up at TDC. If one piston measures lower than the rest, suspect a bent connecting rod. Technicians always have the option to disassemble the engine to perform internal checks, but this approach is time-consuming and doesn't always locate the problem. To help prevent these problems, a tool called a borescope allows technicians to inspect internal engine parts without disassembling the engine. A borescope can save time, but it also avoids hassles such as broken clamps, torn hoses, and the cost of new gaskets. Using a borescope to confirm internal problems can also help justify an engine teardown to the customer. Borescopes come with rigid or flexible ends. While a flexible borescope fits into curved passageways, rigid borescopes cover about 95% of all automotive applications and provide a superior image for less money. In addition, rigid borescopes hold up better in automotive service, since they can take more abuse without damage. To use this tool, technicians insert the borescope tip through the spark plug hole or injector port. Therefore, the borescope shaft must fit through these openings. To see to the side, rigid borescopes use angled tips. Using these tips allow you to see images to the side of the borescope shaft. While expensive, a camera attachment allows you to take digital or video borescope images. This option allows you to deliver visible evidence of problems to your customers, rather than just a verbal description. When inspecting the intake manifold, focus on the intake valve. Worn or defective fuel injectors flow too much fuel and wash away carbon deposits on the valve. A bad valve guide or guide seal deposits excessive oil on the valve and valve stem. Finally, this inspection can find mechanical problems such as a slipped valve guide. After checking the intake system, use the borescope to inspect the combustion chamber. First, check the piston face for excessive carbon or mechanical damage, or oil washing at the edge of the piston due to a bad oil control ring. Also compare the piston tops from cylinder to cylinder. If you see a clean and shiny piston top, suspect that a head gasket leak is steam cleaning the piston top. Foreign objects leave imprints on the piston top and could crack the edge of the piston, or even create a hole in the piston top. After checking the piston top, look over the cylinder walls for scuffing or other damage. Pay special attention to the carbon witness line. The top piston ring creates this line, and using it can help identify a bent connecting rod. The carbon witness line shows the highest point the piston has traveled and should be the same for all cylinders. When there's a difference from cylinder to cylinder, the lower witness line indicates a bent rod. After the cylinder wall inspection, check the combustion chamber. Look for mechanical damage or a bent valve stem that prevents the valves from fully seating. Also check for cracked valve faces or burned valves or seats. Scopes also allow technicians to perform other checks inside the engine. Openings in the valve cover allow you to view the valve train for mechanical or sludge problems. Under the car, inserting the borescope through the oil pan drain plug opening allows a view of the crank and oil pump. This check may identify crankshaft or connecting rod faults or excessive sludge buildup. All bearings provide a low-friction surface for rotating shafts. But rotating shafts can also move back and forth. We add bearing surfaces to prevent this movement. We call these bearing surfaces thrust washers or thrust bearings. As these components wear, more and more back and forth movement occurs. We call this motion end play, and the service manual specifies the maximum amount of end play or movement allowed. Typically, we check end play after engine removal using a dial gauge. However, you can also use a feeler gauge between the thrust bearing surface and the rotating shaft to measure end play. If end play is too great, components may strike the engine or transmission case. In addition, sensor wheels may not match their pickups, causing an intermittent sensor signal fault. On vehicles with manual transmissions, clutch pressure may accelerate thrust-bearing wear. To check for this problem, press the clutch pedal while watching the crankshaft pulley. If you see any movement, remove the oil pan and inspect the crankshaft thrust-bearing clearance. In some cases, you can replace excessively worn thrust-bearing surfaces without engine removal. This concludes our module on internal engine inspection. We hope you can use the techniques shown here to better inspect and troubleshoot internal engine problems. The engine section of the service manual includes inspection procedures and measurement specifications for many engine parts. But there are also sections that do not provide specifications. Looking through the service manual, we can find the following statements. Inspect each connecting rod for cracks and heat damage. Inspect the splines for excessive wear and damage. Check the shaft bearing surface for scoring and excessive wear. When you encounter such statements, you must visually inspect each component and make replacement decisions without the benefit of specific pass and fail criteria. This module provides guidance on how to perform these visual checks. During engine inspections, check the service manual text for wear specifications. Wear specifications include phrases such as no more than or not to exceed. If the procedure does not include a specification, the technician must use their best judgment. The following sections provide procedures you can use to evaluate wear. Always use new condition as the starting point for any visual inspection. New mechanical parts share several characteristics. At each bearing surface, the parts have a smooth machine finish. Gear teeth and cam lobes have consistent, repeatable shapes. Component color is consistent, and machine marks such as cross-hatching repeats evenly across the entire wear surface. These characteristics change during use. Machined surfaces show wear patterns from friction, and parts can crack, bend, or distort. Parts may also discolor during use or show tool witness marks. A visual inspection helps determine if a part is damaged or ready for further use. As you know, engine wear occurs due to internal friction. While oil greatly reduces friction inside the engine, cold startups, mileage, and poor maintenance all lead to wear. During a visual inspection, check for wear at the bearing surface of each component. Even wear across the bearing surface points to normal wear. Parts that exhibit normal wear without a wear specification typically do not require replacement. If the wear pattern is uneven or noticeably deep, perform the check shown in the following sections. On cars with high odometer readings, check for symptoms of excessive wear. Symptoms of wear from excessive mileage include oil smoke, low compression, or leaking valves. Next, check for sludge or other signs of poor maintenance. As you know, engine sludge indicates poor maintenance, but poor maintenance also causes gasket and seal damage and can increase timing chain clearance. If an engine has oil leaks or the timing chain clearance exceeds specifications on a low mileage engine, keep an eye out for excessive wear. Finally, check the component fit. If two machined components fit together loosely, you've found excessive wear. Additional clues to look for include scoring and galling. If you see these problems, consider component replacement. Mechanical damage occurs due to metal chips, broken parts, or foreign objects that interfere with mechanical operation. These contaminants can crack, chip, or bend engine components. Anytime you see a crack, you're looking at a potential failure point. Cracks can occur due to mechanical interference, over-torquing, or defective castings. Cracks can be identified visually, but the industry also uses dye penetratant or magnetic inspection procedures to identify invisible cracks. These procedures are not necessary for parts calling for a visual inspection. Mechanical damage can also cause chipping. To identify chipping, look for asymmetrical patterns, particularly on gear or synchronizer teeth. If you see multiple chips, locate and remove the cause of the chipping and clean out any metal chips or contaminants in the engine and transmission. Foreign objects, overheating, or abuse can bend and warp parts. Foreign objects tend to create obvious bends, while overheating tends to warp parts out of shape. Signs of overheating include coolant leaks or burned oil residue. Abuse usually means over-revving the engine, which often occurs due to missed shifts on manual transmission cars. To check for bending, compare parts to a known good part and confirm that machined surfaces are flat and square. Witness marks indicate contact between two parts. These marks may indicate normal wear, such as where bolts mounted the part, or pry points that occurred during disassembly. These are wear and tear witness marks and don't call for part replacement. However, witness marks can also indicate impact points that bent the part. Always identify the cause of these witness marks prior to completing the repair. The source of the witness marks that resulted in damage must be removed. Discoloration may not indicate a problem. As we said in the opening, dyes or oils can affect the color of components, so a color change on its own is not a cause for concern. However, dark colors at a friction point indicates overheating and potential heat damage. Check for overheated engines by looking for blackened or flaky deposits in the engine. When engines overheat, they can leave carbon deposits from the consumed oil. Remember those inspection statements we listed earlier? Let's hear them again. Inspect each connecting rod for cracks and heat damage. Inspect the splines for excessive wear and damage. Check the shaft bearing surface for scoring and excessive wear. When you encounter these statements in the future, be ready to perform the following checks. Use like new condition to help evaluate parts. Ask questions like, where are the machined surfaces? Where would you expect to see normal wear patterns? Evaluate the engine condition during a visual inspection. Ask questions like, does the engine show signs of abuse or excessive mileage? Do other parts show damage from mechanical damage? Only replace damaged parts. Galling, scoring, and cracks indicate immediate replacement. Parts with even wear or minor chipping should be ready for continued service. Once you evaluate the engine using these overall checks, you can be confident you've performed a quality visual inspection.